Hi Pre-Calc, we're going to do 3.2 today. That's your logarithmic functions and their graphs. If you have a log that is base 10, that is called a common log. If you have a log that is base e, we don't write base e, we give it a nickname. That's called ln of x, and that's a natural log. So you want to remember that a common log is base 10 and a natural log is base e. And again, it's going to be written in its nickname. It's never written like this. You'll see it written like this. So the first thing you want to be able to do in this section is be able to write a log in an equivalent exponential form. Now that's going to confuse you for a moment because logs and exponentials are inverses if you swap x and y, okay? If you swap x and y, that is what makes the inverse, not actually converting the form. So without swapping x and y, I can write the log like this. So notice how it works. Here on the exponential form, it's the base to the exponent equals to y. In the log form, it's log base b of y equals the exponent. What was the exponent over here? So logs equal the exponents. So I wrote 2 in the equivalent form. So if you have 2 to the third equals to 8, the equivalent logarithmic statement of that is log base 2 of 8 equals to 3. And again, notice the log equals what was the exponent over here. If you have e to the negative 3/4 equal to 0.4 and change, this, remember, if it's ln, that's already base e, so this means it's base e of 0.4723 equals what was the exponent over here. All right, so you have to be able to go back and forth. I wrote it in this sort of special notation to sort of help you see it. So b to the e equals y, so therefore log to that b of that y equals to e. I won't spend too much time here, but just so you can sort of see how to do this. One of the reasons people like to know what the form conversion is that it's easy for them to rewrite it. So like for instance, as a log, this might be hard for some people to figure out, but if they convert it from this form to this form, all of a sudden it's a lot easier. So this, in converting the forms, it looks like this. It's the base, which is the 25, to the exponent, which is what we're trying to figure out, equals to 5. Now some people might know what this answer is. If you don't, what you do is you can say 5 squared to something equals to 5. I'm going to actually call this a y just so we have a variable. Or 5 to the 2y equals to 5. And then you can use the one-to-one property, which says if the bases are the same, the exponents have to be equal. So if 2y equals to 1, then y equals to 1/2. Okay? But you may have recognized that it had to be 1/2 here because the square root of 25 is 5. But if not, you can use the property to solve. I'm just going to do that again so you can see it. Log of 10 equals to what? I'll call it y. So now the base here, if there's nothing written here, you have to recognize that the default is 10. Okay, that's really important, otherwise you're going to get confused. The default base is 10. So if nothing is written here, it's going to be, you assume it's a 10. If nothing is written by the log for the base, you assume it's a 10. So now I'm going to use the form. So 10, this little 10 to the y equals to this. So therefore you can see that y here has to be 1. Because this has to equal this. All right, we're not going to do a ton here. I'm mostly going to focus on the graphing so you can see it. The big thing about logs is they have a domain restriction. They don't take negative numbers and they do not take 0. All right, so when you're going to draw this, you're going to notice it's only on part of the graph. Now for some people, they don't like working with, they like to put everything into their calculator, and if that's you, then you can always convert the base. If your calculator can't do any base, then you can always convert the base, and I'll show you that in a minute. This is the formula for that. But I'll work some out here, so let's see. So that stuff, that rewriting I did before, that you can do for this if you don't understand how I'm getting these answers. All right, so this is going to equal to 0 because 2 to the 0 is 1. So I'm sort of doing it a little bit backwards so you can see it. Now I've let x be 2. So this has to be a 1 because 2 to the 1 has to be 2, right? I'm saying it to you as if it was written in an exponential. This would base exponent has to be that. So that has to equal to 1. Okay, see if you can do this one. 2 to the what would make 4? Hopefully you saw 2. 2 squared is 4. All right, let me do another one that's base 2. Let's do 8. 8 is base 2. What would this be? 2 to the what is 8, right? It's 2 to the third. 2 raised to the third is 8. So like this. See if you can do a negative 1/2. That one's a little tough. Oh, sorry, this doesn't take negative 1/2. Oh, yes, we can do negative 1/2. No, this has to be x is greater than 0. What number am I trying to think of? Oh, 1/2. I'm trying to think of 1/2. Sorry, I couldn't figure out what my brain was doing. I'm thinking of 1/2. Okay, so log base of 2 to the 1/2, what would that equal to? That's what my brain was doing. It was doing negative 1. Because 2 to the negative 1 makes 1/2. All right, so let me put the points, let me put these points up. Let me see how far in. All right, I'm already at 6 minutes. All right, so you know how exponentials have horizontal asymptotes? Logs have vertical asymptotes. Logs have vertical asymptotes, so it will be right on the y-axis unless you push the graph left or right. All right, so at 1 we're at 0, at 2 we're at 1, at 4 we're at 2, at 1/2 we're at negative 1. All right, so this is what the shape looks like. Some people say it looks like a sideways L. It's going to ride right against the asymptote here when you get to the left side of the graph. All right, so that's what this shape looks like, and of course you can do all the things to it. You could push it left, you could push it right, you could push it up, you could push it down, and so on. The higher the base, just the tighter it's going to come in. Let's see here. Okay, let's leave it at that for now. I will do more graphing with you. This is if you just want to check for yourself. So like if I say base 2 of 8 is 3, and you don't have base 2 on your calculator, what you can do is you can write it either by base 10 and put this in your calculator. You'll see that this equals to 3, or you can use ln. And you'll see that that equals to 3. So if you just want to check that in your calculator, you can do that. Just make sure you close the parenthesis. If you don't close the parenthesis, your calculator won't give you the right answer when you put these numbers in. So like for instance up here, if somebody doesn't like the way I did this sort of in my head, they might rewrite this problem as, and then they can put whatever x value they want here. They could do, they could let x be 7, then ln of 7 over ln of 2, and then graph that number. Okay. All right. You know what? Let me just stop this one here, and then I'll pick up doing more graphs. Catch you soon. Bye bye.